Will we have a space base on Phobos? Will hibernation help us cope with long-distance space travel? How will Starship be returning from Mars? Answering all these questions and more in The Question Show. It's time for The Question Show. Your questions, my answers. As always, wherever you are across my channel, if a question pops in your brain, just write it down. I'll gather them up and I will answer them here. All right, let's get into the questions. Joe Nerf Herder. You mentioned stations everywhere, but Phobos, why not have a station on Phobos? So this is a question in relation to all of the places that I believe that there will be a human presence in the solar system. Obviously, we live here on Earth. We will eventually have a permanently inhabited station on the moon. Of course, probably in low Earth orbit, another space station after the ISS goes down, or it's the Chinese space station. Then we will probably have a permanently inhabited base on Mars. We'll have a permanently inhabited base on a couple of asteroids. But Joe Nerf Herder is absolutely right that I missed one of the most interesting places for us to put a space station, and that is on the moon of Mars, Phobos. What makes Phobos really interesting is that although it is very far away, it is all of the way to Mars. It is sort of, in terms of delta velocity, much easier to get to than to try to go down into the atmosphere of Mars and then get back up from the surface of Mars into orbit again. And so, there have been some really interesting plans. I've covered these many times in the past on Universe Today, and I've even done videos about how we should do a station on Phobos. And I am 100% on board for this plan, because what it does is it gives you a staging place that is in orbit around Mars, very close to the surface of Mars. You can fly spacecraft from Earth to Phobos, set up on Phobos, refill your propellant tanks for your lander and your ascent vehicle, make sure that everything is ready, and then go down to the surface of Mars, take off from Mars, back up to Phobos, and do this process over again. If there is an emergency, you can send people from Phobos down to the surface of Mars and help rescue them. So I wouldn't be surprised if instead of actually going to Mars, people come to the realization that Phobos is a great place for us to build that station that gets us almost all the way to Mars, and yet sort of breaks up this journey into two logical pieces that makes the whole thing a lot easier. So yeah, my vote for Phobos. Apropos of wet snow, if human beings went extinct, how long do you think it would take for life to evolve another spacefaring life form? If it took 4 billion years to get to now, is this life's only shot to leave Earth? We have no idea, obviously, if any of the other life forms on Earth will evolve the level of intelligence to do tool use and to be able to space flight and all of these kinds of things. And it's kind of interesting that intelligence is this sort of divergent evolution where you've got us, there's octopuses, like they're a mollusk, you've got parrots, so like birds, you've got cetaceans, dolphins, and they're also mammals. So, they're related to us and have a certain amount of sort of similar brain architecture, but very different creatures also have arrived at intelligence. And so you could imagine with the value that intelligence brings in terms of being able to take over the entire planet and subjugate all of nature to your will, that another life form would eventually come up with that. Now, one of the sort of really interesting ideas is that we as human beings have extracted all of the easy resources on the surface of the Earth. When you think about all of the mines, we've done tremendous amounts of sort of mining exploration. We've harvested all of the places where it's easy to get oil, coal, things like that. And that now we're having to develop very advanced technology to be able to go after oil that is mixed in with sand, or oil that's at the bottom of the ocean, or oil that is in giant caverns underground that you have to pump in carbon dioxide to get the oil back out. Like, it takes a certain amount of technology. And so, I don't know if it would, for us, like, let's say that there was some kind of disaster. We had, some nuclear wars or an asteroid strike or something like that. And it took us several thousand years to get back to a level of technology. it actually would be very difficult for sort of the next civilization to try to pick up the pieces and try to go after the stuff after everything had rusted and all of our sort of stuff was gone. And yet all of the easy to grab stuff we had taken it. And so I think that's a really interesting argument that in fact, it would be a really hard time for octopuses or parrots or whatever to kind of take that next level. But it is really fascinating that the intelligence has evolved multiple times from entirely different sort of genetic heritage. And so it gives me hope that, yeah, if we mess this up, that the octopuses will take over. And like, who wouldn't love to see octopuses flying in space in spaceships? I think that'd be awesome. HFN Noble. For long distance space travel, how will human bodies be able to cope with radiation, especially as we leave the solar system? I think our ability to leave the solar system is going to be quite a ways off. I think we are looking at centuries before we attempt to leave the solar system and travel to other star systems in our fragile meat bodies. But, we're going to be sending robots, hopefully by then or sooner than that. But still, if we want to send humans even on very short flights, if we want to be able to go to Mars, if we want to be able to go to those asteroid belts, the asteroid belt that I mentioned, or set up that base on Phobos, or even have a base on the moon, then the radiation is a big problem. When you're out in space, like say you're standing on the surface of the moon, you are experiencing about 200 times more radiation than you experience on the surface of the Earth. And it can be even worse. If there's a very powerful solar storm, you can receive a lethal dose of radiation in a couple of hours, and then you're dead. There's no way around it. Otherwise, you're going to be getting that longer term radiation, the one that gives you cancer 10 years, 20 years, 50 years down the road. And so, both are to be avoided. And so really, people have been thinking about what are the kinds of ways that we could protect our astronauts from radiation for decades. You can go back to the 1960s and there are papers written by NASA where people are thinking about ways to limit the amount of radiation that astronauts are going to get. And generally it comes down to two solutions. One is some kind of artificial magnetosphere, the kind of thing that we have surrounding the Earth, but let's build one with superconductors and electrical current and magnets. And the problem is, and again, those papers exist. Those papers you can go back to the 1960s, 1970s and read papers where people are thinking about how to build an artificial magnetosphere. And then there's stuff in the 80s, stuff in the 90s, stuff in the 2000s, 2010s, 2020s. There are still, like the European Space Agency very recently put out a call for papers where people are trying to come up with ideas. I've interviewed people on this channel for people, NIAC has given out awards for people trying to create artificial magnetospheres. And the result always seems to be that the amount of energy that's required is just too expensive to try and create this artificial magnetosphere. We've got an entire planet with a core of iron and surrounded by liquid that is thousands of kilometers across. And that gets us our magnetosphere. Now, the other solution is protons, stuff. Dirt, water, lead, and you definitely need some, but you don't need a lot. And so just like in general, you need about a meter of material between you and space. And so, a lot of really interesting ideas center around how can we take advantage of the material that's already out there in space to protect our astronauts on these trips. So for example, you could take an asteroid, burrow into the asteroid, set up your station inside the asteroid. You're protected by the exterior of the asteroid. You can use the material in the asteroid to maintain your base. There's going to be volatiles, water, as well as iron and titanium and aluminum and oxygen and all kinds of stuff that you might need in your asteroid. People have proposed that you could use comets. You could actually, drill into a comet and protect yourself. And then you're protected by water ice. So, yes, that if we plan to do any long-term space flight, we're going to need to figure out a way to get material to surround us, that the spaceships, the long-term spaceships of the future are going to look like they're made of ice, or they're surrounded by rock, or they're surrounded by, a meter of metal. And that's what it's going to take for us to be able to survive long-term on these long-term space flights. But once you do that, once you're able to pay the price to be able to accelerate that much mass, then you can be protected from that radiation. Want the extra parts of the live stream that aren't in this edited version? You can sign up for a special patron-only podcast feed and get the overtime segments, as well as other special behind-the-scenes episodes, including our monthly patron-only question show. Thanks to everyone who has already subscribed, and welcome to our recent newcomers: Monkey Lovin', John Rasnick, Dave Steiner, Josh Bressers, Kevin Trass, and Rolf Bandsma. Join the club at patreon.com/universe today. B-Space777, how can a human-rated Starship return to low Earth orbit from Mars after being dormant and exposed to low temperatures, radiation, and fuel boil-off? So just like the human body, if we send a spacecraft to Mars and want it to return to Earth, then it's going to go through all kinds of issues down on the surface of Mars. And the whole plan with the bringing a mission back from Mars is that you don't have to send the fuel on the spacecraft when you go to Mars. You just have to be able to land on the surface of Mars. And then you manufacture your fuel on source. And this is the genius idea that came from Robert Zubrin with his book, The Case for Mars. And this is one of the books that got me inspired in becoming a space science journalist, was that I read that book and I'm like, we've got to go to space. We've got to build a city on Mars. This is amazing. I've later toned down my perspective on that and become a lot more skeptical and even cynical, but still, huge props. And the incredible stroke of genius, the leap that Zubrin made with his Case for Mars and sort of his general thinking was that up until this point, everyone thought, well, if you're going to send a mission to Mars, then you're going to have to, you're going to have all of the fuel to get to Mars. But then the spacecraft that you send there is also going to need all of the fuel to bring your astronauts back home. And his idea was, well, what if we just use this very well-known chemical process that can turn carbon dioxide and water into methane, and then you can use that methane as your fuel to get your spacecraft off of Mars and back home. And so instead of sending a fully loaded spacecraft to Mars, you send an empty spacecraft to Mars. You land on the surface, it then turns on its generator and begins extracting this material out of the atmosphere of Mars, makes enough fuel so that it can have the return flight home. Then the astronauts arrive on the next ship, they get off, they do their Mars exploration thing, they get into the fully fueled ship, and then they come home. And if you watch The Martian, that was what they were doing in there. So if this is going to work, then, it has to be proven. Like, there's a lot of engineering challenges, but every part of this is known science, has been engineered in the lab in various scales. It hasn't been tested on the surface of Mars, but in fact, there is a experiment on the Perseverance rover that tested making oxygen on Mars. We know you can make oxygen. So really, this is probably going to be the system that SpaceX is planning to be able to bring missions back from Mars. And so in the first stages, they're probably just going to land a Starship on Mars, and then it'll just sit there forever. But later on, they'll send one that's going to be a fuel factory that will try to build its own fuel on the surface of Mars, and they'll figure out whether it's successful or not. And eventually they will figure that out. And so really, this idea of in situ resource utilization, this is the only solution that's going to really work to bring heavy payloads off of the surface of Mars and bring them back home. But there are so many challenges. And I think this is where my, 25 years of experience in watching aerospace companies try to tackle some of these problems is that the devil's in the details, that it's about acquiring the sources of water on Mars. Where are you going to go? Are you going to land near the poles? It's about running your equipment in a way that is reliable over a long period of time. Where are you going to get your power from? Are you going to use solar panels? Solar panels don't work as well on Mars as they do on Earth. You need vastly larger. You're going to use nuclear RTG. Maybe, they're hard to get a hold of, especially for private companies. So there's a million details that will come. And then, of course, it's like, who's going to pay for all this? And what is the revenue to be able to continue this ongoing multi-billion-dollar investment into developing the technology that will return vehicles from Mars when there's no profit to be made? So engineering-wise, is it possible to do all this? Yeah, it all seems feasible. Nobody's ever done it. And so people are right now planning the hardware to try and make this happen. Who knows how long it's going to take? My instinct is that because there is no obvious way to make money, it's going to take a lot longer, be a lot more expensive, and just delay and delay and delay. People are going to get very frustrated at how long this process of actually sending spacecraft to Mars and bringing them home, having them refuel there and come home. But, the Chinese are planning to send a sample return mission in 2028. Like 4 years from now, China is planning on sending a sample return mission, and the sample return has to have the fuel on board to be able to pick up material and come back to Earth. So, by 2031, we'll know whether you can do a scaled down version of sample return for Mars. And people are just big samples, right? Casey Ream, even within the solar system, we don't know how to survive the radiation, but is it true that the answer could be to hibernate like bears? So I think it's important to distinguish two things here. The first thing is the radiation, that even if you did hibernate like a bear, you would still experience radiation. It would still shorten your life, increase the chances of you getting cancer and all kinds of other stuff. The benefit of hibernation, and it's the same reason that bears do it, is that it decreases your need for calories, for breathing, for water, for all these kinds of things, waiting through winter until you can sort of come back out in the springtime when all of the food is returning again, and then you can fill up and grow fat. And by the way, here's a picture of a bear looking through my window. Speaking of bears. And so NASA and other space agencies have absolutely looked into this idea of hibernating astronauts to decrease the amount of resources that they're going to require on a long trip through space. And there's a couple of ways that you can do this. And actually, people have been testing out this idea of putting a person into a coma and then decreasing their body temperature so that they're really just above freezing, and that they can keep them alive for long periods of time. When people fall into water and they nearly drown and they need to bring them back very carefully, they can sort of keep their temperature lowered. But it's sort of shown that it seems like you can keep people in this state of hibernation for a long period of time and really not have them suffer any kind of health issue. And so NASA actually had a NIAC grant a couple of years ago where they investigated this very idea. Could you use the same technique that's being used in hospitals, but on the astronauts? The mission would launch, and one of the astronauts would get to be the awake one. And they would go and they would put each of the astronauts to sleep in the spaceship. And then that would dramatically reduce the amount of food and water. The astronauts would be breathing just a couple of times a minute. Their hearts would slow. Maybe they would have some kind of nutrients that would be attached intravenously that would slowly give them the food and vitamins and stuff that they require. And that would mean that you wouldn't have to launch with so much material, less food, less water, less air. And so you could have more payload, more cargo, more science, or more astronauts. And only when you actually arrive at your destination, like Mars, would you actually wake everybody up, and then you would land down on the surface of Mars. That's a really interesting idea. And it seems like it would be very effective. I'm not sure people would want to be put to sleep on those long trips, but, I think with the way the research is going, I think someone will try this out in space at some point. The longer term idea is there a way that we can actually, properly freeze you solid in the way that they do, when you think about Aliens or Avatar, that you go into this cryo sleep chamber and then you wake up at your destination and you've experienced no time whatsoever. And the problem is, of course, if you freeze a person, they die because ice crystals pop all of the blood vessels and destroy the tissue in your body, and you can't survive that. But there are creatures here on Earth that can handle being frozen solid, frogs, and there's other things. And people have been trying out different techniques to be able to lower the temperature of living tissue down to the freezing point, and are seeing some kind of success. So, it feels like science fiction today, but you can imagine some future where we can actually freeze people solid as long as is needed into the future. So stay tuned. This is an evolving science right now. All right, those are all the questions that we have in this episode, but of course there will be a second episode coming out this week, so stay tuned for that. Now, I'm going to chat about the changes to the live stream schedule, but first, I'd like to thank our patrons. Thanks to Abe Kingston, Adam Schaefer, Andrew Gross, Bear Lake Roofing, David Giltonen, David Matz, Dennis Alberti, Dustin Cable, James Clark, Jeremy Mattern, Jim Burke, Jordan Young, Josh Schultz, Paul Rohrbach, Spiderswap.io, Stephen Fowler Munley, and Vlad Shiplin, who support us at the Master of the Universe level. And all our patrons, all your support means the universe to us. So a couple of weeks ago, we did the first Europe time stream, and that was where we did the live question show on 8 a.m. my time on Monday morning, but that was in the evening for people in Europe and the UK and so on. And just last night, we did the Asian time stream, and that was 10 o'clock Sunday night for me, which worked out to be 5 p.m. for people in Sydney, Australia, and reasonable times for people in New Zealand and Japan and so on. And once again, it was great. We had a ton of people show up. And so I think we're going to consider this a rousing success. We will continue on. And so every second episode is going to be in my native time on Pacific coast of Canada. And then we'll alternate. 1 week, it'll be Canada. Then it's going to be Europe, then it's going to be Canada, then it's going to be Asia, and just keep going through that cycle. And the second thing I want to let you know is that we're going to be doing more of the Telescope live streams. We've got some really fun themes planned. So hopefully you will see the next live event. It's going to happen probably this week, Tuesday, Wednesday. And that is I'm going to do a time travel stream where every object that I look at is a little bit farther away and a little further back in time. We'll think of sort of different themes. My hope is I can go from objects that are right next door all the way out to looking at quasars all in one night, looking through a telescope. So definitely check out that. All right, we'll see you next time.